guys, so here's our next video. I've got another way to make videos, so hopefully you guys like this one. As you can see, I'm not in school to make this. I'm going to try and make these from home. So let's get started. Alright, and this lesson is going to be an introduction to radians. Intro to radians. Alright, and radians, you guys might kind of have heard of radians before, alright, but usually the only time you guys have heard radians is before when we did trig, you know, sine, cosine, tangent, and we had you put that into your calculator. We always said make sure that you guys go and make sure that you're in degree mode and not radian mode. Okay, so radians are what we're going to start using now, and they're just a different way to measure degrees. Okay, and you might be thinking, that's stupid, I like using degrees, why can't we keep using degrees? But radians actually, in my opinion, make more sense, but they're really, really important, and they really come in handy when we're talking about calculus. So I know that not all of you are going to go into calculus, but radians are really, really nice. So how about we start off with the formal definition of a radian. So I'm going to write the formal definition, and then I'll move into breaking down what it actually means. Okay, so a radian. And if anything, talking about radians makes you sound like a really big math person, and you'll scare all the little freshmen that you're around when you talk about your math homework. So a radian is a unit of measure of a central angle, that intercepts an arc equal to the length of the radius. Okay, so a radian is a unit of measure of a central angle that intercepts an arc equal to the length of the radius. Okay, sounds kind of intimidating, but I promise you it's not. So first off, let me go to a new page. Boop. Alright, so let's talk about circles. Alright, circles are usually what we kind of refer to when we start talking about angles. So if I've got some circle, boop, that looks kind of like egg, but whatever. So if I've got some circle, and let's say, I'll even put it on the axes. Boop. Always label X and Y. Alright, and just for this one, let's say this circle has a radius of 2. Right, it has a radius of 2. Hopefully we remember from geometry that a central angle is just the angle that happens right at the center of the circle. Okay, so just like we've been doing with normal angles, we have the initial side, we have the terminal side, and the vertex of our angle is always at the center of the circle. That's all I'm talking about here, all right? No tangent chord angles or secant whatevers, nothing from geometry. Okay, we're just talking about these central angles. Okay, so if we have this circle, and let's say it's got a radius of 2, what I'm going to do is I'm going to take the circumference of the circle, I'm going to take the outside, and I'm going to break it into arcs that have a length of 2. All right, so because my radius is 2, I'm going to break this circle up into, so this is going to be equal to 2, and this will be equal to 2, and this will be equal to 2. As you can see, I'm just kind of estimating here. It's not exact. This will be equal to 2. This will be equal to 2, 2, and 2. All right, this piece right here. So since my radius was equal to 2, I broke up my circumference, or the arc of my circle, into pieces that were also a length of 2. Okay, now for each of these pieces, all right, where each of these little hash marks are, I could break my circle into kind of like little slices. It looks like pizza. Okay? Doop, doop. All right, so each of these pieces that has an arc length of 2 breaks into each of these little wedges. Okay, and if I measured the degree, or I'm sorry, if I measured the angle that was in this wedge, and we'll call that theta, all right, that's going to be equal to the angle measure of this wedge, theta, and this wedge will also have an angle of theta, and they're all going to have an angle of theta, all right? But since my radius was 2 and each of these arcs are 2, this theta, this angle measure, is equal to 1 radian, okay? Remember, for degrees, the symbol for degrees is we take that little itty bitty circle and we put it in the top right. Okay, for radians, we can take a capital R and we can put it in the top. Although most people, they just think it's kind of silly, and they would just say that our theta is equal to 1. They don't bother with the R because they say, well, if it doesn't have a degree symbol on it, then it's definitely a radian. Okay, so it's up to you. But that is what a radian is. All right, instead of breaking up our circle into these things called degrees, instead we say, well, let's take whatever the radius is, and if I break the arc of my circle into pieces that are equal to the radius, that's what a radian is, okay? If my arcs are equal to my radius, I'm using radians. Now, for this example, I had a radius of 2. You could do this for anything. All right, if it's got a radius of 1, a radius of 5, it just always has to correspond. Okay, so let me take another example right here. Okay, and let's take this circle. Boop. All right, this is just any circle. Okay, and let's just say it's got some radius equal to r. So r equals radius. Okay, and I'm going to do this in blue. Now, I'm putting a blue squiggle around everything because I'm talking about the arc of the circle, or what goes around the circle. Looks like a flower, okay? And I don't know why, all right, but for arc, we use the letter S. Okay, doesn't really make too much sense. I don't know who picked it. Okay, so in general, if I'm going to find my angle, theta, in radians, okay, I'm going to do my arc around my circle, so S, and I'm going to divide that by the length of my radius. All right, that's exactly what I did. Let me take a step back here. All right, I took my arc, my S, and whatever my radius was, in this case it was 2, I divided it up by 2 into all of these pieces, and that's what gave me a radian. So that was a specific example. Here's a general example. So my theta, and I'll even put, this is in radians. All right, my theta in radians is equal to my arc length divided by the length of my radius. Okay? Now this is right here, this is kind of the first big radian formula that you guys need to know. All right, so I'll highlight it, or I'll put a highlighted box around it. So that's the first biggie that you guys need to know. Definitely criteria for your formula quizzes that we do every day. Okay? But the other thing is that we can actually take this a step further. Okay? I know. One more step. So, because you guys have actually learned things about arc length already. Alright? And the thing is that in the past we haven't really called it arc length. We've called it circumference. Okay? So, for example, how about we take the unit circle, all right? Told you guys the unit circle was a big deal in this class. Alright, doesn't have to be perfect, just a rough sketch. I'll even put a title on it, unit circle. T. Boop. Okay, we got a unit circle. And let's see, what do we know? Well, first, you know what? I'm not even going to look at the whole unit circle. How about I just look at half of it? I'm just going to look at the top half. Okay? So if I'm looking at the top half, if I wanted to know the arc length of the whole circle, that would give me the circumference equals pi times diameter, or we can write that as 2 pi r. That's if I'm looking at the whole circle. But if I just look at that half circle, the semicircle, that's half of the circumference. So if I divide that by 2, I get pi r. Correct? So the length of the arc of my semicircle is equal to pi over r. All right, well, we just had a formula on the last page that said that if I want radians, I'll make a little box down here. If I want radians, my angle measure in radians is equal to arc length divided by r. Well, the arc length of a semicircle, we just said was pi over r divided by r. And here the r's are going to cancel. Boop. And we're just going to be left with pi. So what we just figured out is that if we're looking at the radian measure of a semicircle, that's equal to pi, which is actually kind of a big deal, because that means that this angle right here, the angle of the semicircle, which we all know in degrees is 180 degrees, that's the same thing as pi radians. Okay, this is like the key. This is the key to radians for the next however many years that you take math. All right, because like I said, radians are a big deal, and they're going to come up in calc all the time, and the rest of trig. All right, and a big thing is that we need to know how to convert from degrees to radians and radians to degrees. And this right here is the key. Okay, I'm going to put it on its own page. Boop. 100, I'm going to write it big. 180 degrees is the same thing as pi radians. And like I said, if you want to put this little, I'm going to make it little, this little r in the top for radians, so you can, but usually like I said, most people say, well, if you're going to use the little circle thing for degrees, then we just won't write anything for the radians. All right, so this is the big deal. Because now, if we know that 180 degrees is equal to pi radians, we can set up proportions to find out all these other degrees and convert them into radians. All right, but that's going to be the next video that I want you guys to watch. I'm going to kind of do a two-parter. So hopefully you guys got all this down, and then in the next video, I'm going to do some more examples. Let's get out of here.